Hi guys, this is Dr. Joseph from Precision School of Management. Today we are going to see how to use Excel to do a statistical tool called as regression. Regression is a statistical tool which we use to find the relationship between dependent and independent variables, and also it is being used for predicting something for the future. Now in this example, let me explain the data sheet. You have a data sheet with 20 records which has the data of the cost of production for almost 20 months, and the company produces 3 models: model A, model B and model C. So if you take this first record, this total cost of production includes the cost for producing 515 numbers of model A, 541 numbers of model B and 928 numbers of model C. So like this, for every month we have 20 months of data. The task given is, using regression function, we have to predict the monthly cost for producing 1200 numbers of model A, 890 numbers of model B and 1000 numbers of model C. So this is what the prediction I was talking about. In this case, we know about the regression equation. The simple linear line equation is y is equal to mx plus c, or you can say y is equal to bx plus c, where y is our dependent variable and x is our independent variable, and b1 is the multiplier and c was the constant. But now here, since we have a number of independent variables, the equation will be like this: y is equal to constant plus b1 multiplied by x1 plus b2 multiplied by x2 plus b3 multiplied by x3. So here we have 3 independent variables, which are the number of units of model A, model B and model C that are going to be produced. So in the task we have the values of x1. x1 is 1200, x2 is 890 and x3 is 1000. If we are able to know the value of the constant b1, b2 and b3, then we can construct this equation and then we will get the y. We could obviously predicted the dependent variable, which is our total cost. So our objective is to find the b1, b2, b3 and the value of constant, so that we can predict the total cost. In order to do that, we use the regression function. To use the regression function, we need to install an add-in called as data analysis. So you have to go to the data menu in the menu bar. In the last, you should have this data analysis. If you have not installed this add-in already, this won't be there. I will tell you how to install this add-in. So you have to go to File and you have to go to Options, and then you have to click on this add-ins, and here Manage. This list box, you have to select Excel add-ins. To click on Go, and then here there are a couple of options where you ensure that there is a tick mark against the first option which says Analysis Tool Pack, and then the moment you click OK, you should get this option which is Data Analysis. Since I have already installed, I have this option. So we have to go to Data and you have to click on the Data Analysis, and then you will get the Data Analysis dialog box where you have lots of statistical tools and functions available over there. So we are going to use the regression function. So I click on regression, click on OK, and then the regression input dialog box open where we have to feed in the input dependent variable, which is y, and the input independent variable, which are x. So here y is our cost, so I have to select from the label here the header of the table, from cost till the last I have to select, and then when I release, You can see here that particular column is inputted as the y range. Then I have to input the x values. So in this case, first I have to click inside this box, and then I have to go to the table. In this case, we have 3 x, x1, x2 and x3. So nothing but the number of units of model A, model B and model C. So we have to select all the 3 independent variables together. So how do you do that? I just left click at the center of this first cell, which is C4, hold the mouse button down, move it to the right, select all the 3 headers and then just move it down till I select the entire range of cells. So now I have given input y and input x. Then you have to click on this checkbox which says labels, because by clicking what we are telling Excel is the first input in our data table is the first header line carries the labels. They are the names of those columns. So Excel should not consider it as a number input, and it should not consider it for calculation. So if you don't select this option, Excel might take that Excel will take that header as one of the input, and your output may be distorted. So you have to give you have to make sure that there's a tick mark on this label checkbox, so that Excel will understand that the first row is a header. And then now you have to give the output where you want to display the output. So click inside this box, and then you just, so for this exam output I am going to select F4 over here, and you have to just press OK. So since I pressed F4, now Excel will give me the output over here. So you must have received a brief summary of the output. So let me just expand these places so that I get a whole number here. Yes. So we should know how to interpret the result, otherwise the summary is of no use. But before that, let us construct the equation so that you can understand, and then I will explain. So we have x1, x2 and x3. x1 is 1200, x2 is 890 and x3 is 1000. And to construct the equation, we need the values of y values of constant b1, b2 and b3. So this output has 3 tables: this regression statistics, ANOVA table and the coefficient table. So here we have this particular section which says coefficient. So here we have 4 items: intercept, model A, model B and model C. These are the values which we require to build the equation. The value against the intercept is our constant, the value against model A is B1, the value against model B is B2 and the value against model C is B3. So that is more than sufficient for us to construct the equation. So we construct the equation here. We start with equal to y is equal to, this is constant plus we need to have the values of b1 multiplied by x1. So we have a multiplication term. When you have a multiplication term, then we have to put it in brackets. So b1 multiplied by x1 close bracket plus we need the next multiplication term, which is b2 multiplied by x2 close the bracket plus open bracket, b3 multiplied by x3 close the bracket, press enter. So this is the total cost which we are supposed to find. So our objective is achieved. Nevertheless, you should know how to interpret the output. So here in the regression statistics, this adjusted R-square value is very important. This is the correct measure, but generally people take this R-square value. This R-square value should be greater than 0.6. If it is less than 0.6, we have to reject this equation. If it is greater than 0.6, it means our regression equation is reliable. So we can say in this case it is 0.64. but the more accurate measure is the adjusted R square. And then we need to look at this another table where we have to check this significance F value, which should be less than 0.05. So in this case we have value which is 0.0006, which is less than 0.05, hence we can accept this model. And then so this the R square statistics and the significance F is for the model, the equation, and for the independent variable, to find out whether it is significant, whether it has a significant impact on the dependent variable or not, we have to check this particular column which has the p values. So we have model A, model B, model C and their respective p values. Why do you check that? We need to find out how far these variables model A, model B and model C, that is x1, x2 and x3, are impacting the dependent variable, which is the total cost. So the p statistics should also be less than 0.05. So in our result, this is greater than 0.05, this is less than 0.05, and for model C also less than 0.05. It means that this particular variable, it has an impact on the dependent variable, which is total cost, but the impact of this variable on the total cost is very minimal. In general, when you build regression equation, it's better to have lesser number of variables. The more variables you have, the more complex your model will be. So what is the thing suggested is, if in case you come across a variable which is not having a significant impact on the dependent variable, it's better to eliminate that particular variable and to build the regression equation. So what we will do is we have to rerun the regression one more time, but this time we have to ignore this variable and we have to take only two independent variables in the equation, and then we have to build the model. So I'll show you how to build it, and then let's see whether the presence of this particular x1, whether it is significant or not, then you will understand. So let me rerun the regression one more time. I go to data analysis, regression, okay, and then the y values remains the same, but x values this time I delete it. I have to select only from model B, model C, and then I have to ignore model A. Labels is already selected. Output, let me click this particular cell for my output. I'm sorry, I made a mistake. Before you give any input, you should ensure that you click inside the box. Since I didn't click inside the output box, what Excel has done is it has taken the input in my input box only. So that is wrong. So I have to reselect my input X variables, which are model B, model C, and I have to drag. Yeah, so first I have to come to the output range, delete this, then I have to come down. So I'll give this particular cell, and then when I click on OK, I got the summary output. You have to check the R square, still it is greater than 0.6, which is okay. Significance value of statistics is less than 0.05, accepted. Now you can see model A is not there, only model B, model C is there. So let me build the equation over here to show you the difference. Equal to constant plus open bracket and have b2 multiplied by x2 close bracket plus open bracket b3 multiplied by x3 close bracket press enter. Now you can see here I removed one variable, one independent variable, which is number of units of model A, and remember you can see here I am going to produce 1200 numbers of model A, but I have not included that cost in my total cost calculation. But even then you can see my cost of production, the difference is if I subtract this from this, I'm sorry, let me subtract this from this value, the new value. You can see here the difference is only 366. So it means that the impact of whether you produce 1200 number where you produce 1500 number, but the impact on the total cost is very minimal, and that's why it is advisable to remove one variable. And now our regression equation is very simple. It has only two independent variables. Now let us check the significance of impact of these two variables. So we'll check the p-value. This is again less than 0.05, this is also less than 0.05. It means our regression equation over here is acceptable. But generally we take the adjusted r square, but in this case we go ahead with our r square value, and this is our result. So this is where we use regression, and we try to build the regression function which can be used for predicting for the given independent variables. So you should understand that not only for these x1, x2 and x3, for any value of x1, x2 and x3 you can predict total cost. So say for example I want to find out the total cost for 2000 of x1, 2000 of x2 and 2000 of x3, and this is the value you get. Look at this, even now here I don't have x1, but still the difference is only 25 rupees. So that's why we didn't take it in the regression equation. So this is how we do the regression. Thank you for watching. If you like my video, please subscribe to my channel, and please share it to your friends. Thank you so much. Join me for the next video. Good night.